Good day. Welcome to today's class. I hope you've watched my first video on weighted index number or price index number generally. So if you have not watched my first video on price index number, I will mobilize you to check the link under this video so that you can have access to the first video on price index or index number generally. So if this is your first time on this channel, please kindly like and subscribe to this channel so that when we drop more educative videos you will have access to it. So thank you, and if you are a returning subscriber, God bless you. So in today's class we'll be treating weighted index number. I've explained what index number is. We discussed a lot about index number in our previous classes. So according to what I have here, I said in this index weights are attached to each item. Okay, let me explain what we mean by weighted index number. The one we treated last, or the one I'll be dropping the link under this video, is the unweighted. But whenever we are calculating price index or something, we need weights. So we know that fine, we can calculate, index deals with normally change in prices of goods. We calculate the rate, the ratio, or the rate of changes in prices majorly. So but sometimes we need to add weights of those goods. For example, now let's take for example we have the price of commodity A. Price of commodity A. Now the price of commodity A before was 50 naira, and the quantity, let me not even use commodity, let me use quantity here. Let me use quantity, 50 naira, and probably the quantity purchased then was 450 quantity. Then all of a sudden the price increased to 70. We know very well that this increase or change in price will surely have effect on this quantity. There are a lot of a lot of principles we can hold responsible for that makes us to understand that a change in this price will surely result to this. There are a lot of principles, but that's not the purpose of this class. So but the purpose of this class is to show or to take in consideration quantity when calculating index number. I can put it up. So that is the major reason or the major purpose for this class. So now looking at what we have here now, there are different scientists, or should I say rather some professors, that have postulated a lot of things about one of the challenges of this thing is, okay, look at this now. We have price 50 to 70, then quantity 450 to, like, let's see 310. Now when calculating index number or index number change generally, should we use the old quantity or we should use the new quantity? Should we use the two together or should we use the new quantity? All these are challenges of when they ask you that what are the problem or challenges of price index number, all these are the challenges. So but we have different scientists or different scientists, let's say, that have postulated a lot of things about it. A good example is Laspeyres. Laspeyres, I think he postulated his own in 1864. And when he postulated his own in 1864, Laspeyres explained and convinced us that we should use the last year price. What does I mean by the last year price? I mean the old year price. Okay, look at this now. If I'm to calculate change here, I should make use of the old price, not the new price. How do you know? Let me put it that way. Just like if you look at it last, when you say last year, previous year. So whenever you hear last year, so that is how you can use to identify that Laspeyres is trying to say that we should use the old year quantity. So this is the formula for Laspeyres. Laspeyres believe that the formula for calculating index should be summation of P1 QO over summation P1 PO QO. This is what Laspeyres believe. He believes that we should use the whole year quantity. You should take note that this P1 means the current price, this PO means the old price, this QO means the old quantity, and this QO means the old quantity. So take note of that. Whenever we use P1, we denote current price. PO, we denote last year price. Same thing apply to quantity. So that is that for Laspeyres. We're still coming back to solve questions on what Laspeyres actually believed. So let's look at another one. Another man that postulated or convinced us on another method was Paasche. I call it Paasche. Some people call it Paasche, but I call it Paasche. Yeah. So I think his own was, according to what I have here, Paasche postulated his own 1874. And Paasche believed that instead of using the old quantity, we should rather use the current year quantity. So Paasche believed in this summation P1 Q1. Can you see it is the new quantity over summation PO Q1. So this is what Paasche believed in. It was Laspeyres at first with old quantity. Then Paasche stated another thing, that we should use the current year quantity instead of what Laspeyres has given us earlier. So as a result of this discrepancy, so there's another man sorry for that, his name is Fisher. So Fisher believed that instead of having confusion of which one to use between this and this, why not let us combine the two together? So they are just coming up with different perspective, but at least progressing. So this one believes in the old quantity, this one believes in the current quantity. Fisher believes that, okay, since there is discrepancy, let's join the two together. So Fisher's index, he believed in, oh sorry, there's a mistake I made. There's a multiplication of 100 multiplied by 100 multiplied by 100 for each of all the formulas. So Fisher's believe that we should have a square root of Laspeyres formula without the 100, Paasche formula without the 100, then we multiply it by 100. Let me come again. Laspeyres formula without the 100, Paasche formula without the 100, then we multiply everything by 100. So Laspeyres formula, we have summation P1 QO over summation PO QO, summation PO QO, then multiplied by Paasche formula without the 100, summation P1 Q1 over summation PO Q1, summation PO Q1, then we multiply everything by 100. We multiply everything by 100. This is Fisher's formula. You can see the way with time it continues to progress. That is how we have in different fields. So it starts from a very, even computers, a history of computer, it starts from the first generation when things are not really fine, then proceed to upper and more generation where we have advanced in technology and so on. So same thing applied here. And there's this particular man also, I call him Marshall Edgeworth. That is his name actually, Marshall Edgeworth. Yeah. So what was this Marshall Edgeworth formula all about? Marshall Edgeworth believed that, okay, instead of having issue of whether to use the old quantity or the new quantity, why not add the two quantities together and get their average and use their average? Can you see it's just continue to proceed from this one old, this one new, this one combined the two. This one believes that, okay, instead of all these things, let's just get the half of the quantity and use it instead. So this is Marshall Edgeworth formula, summation of P1 multiplied by this dot here means a multiplication in the mathematics, in statistics. So we have Q1 plus QO over 2, then divided by summation PO times Q1 plus QO over 2. Then this is Marshall Edgeworth's formula. There's just one thing you need to consider. There's one thing you need to take note of, that for every formula you want to write, first write the skeleton. I want to teach you a very simple method. Write the skeleton. What does I mean by the skeleton? The skeleton is simply summation P1 over summation PO. summation P1 over summation PU. If you notice that in every of all these formula, we have summation P1 over summation PU. That is the skeleton. So that is the framework. Let me put it. So this is the framework. So Laspeyres, I said it earlier that Laspeyres, last from the word hell, last year. So previous year, he believe in using old quantity. So just add QO, QO. You grab. So you do the same thing for Paasche. So you know that, okay, if Laspeyres is last year, then Paasche will be current year. So Q1, Q1. Then join the two together for Fisher's and get the average for quantity. As simple as that. So let's now proceed to solve a question. A question will be displayed on the screen. So we are going to solve it together, and let's see. Now, from the question we have displaying on the screen currently, it said, use the following table to calculate the price index numbers for the year 2006 by taking 2001 as the base year and using the following methods, using Laspeyres, Paasche, Fisher, and Marshall Edgeworth. So we have commodity A, B, C, D. We have the old price, as you can see, the 2001 price. We have 14, 13, 12, and 10. We have the 2001 quantity, 45, 15, 10, and 5. So we have the 2006 quantity, which is 20, 19, 14, 12, price rather. Then the 2006 quantity, now we have 35, 20, 10, 8. So they said we should use 2001 as the base year price. So from what we've read to our ears, so what we need to do whenever you see a question there is to indicate the old year and indicate the current year. So how do we indicate the old year? I said it from the beginning of this class that we use PO, for old price, and we use QO for old quantity. We use P1 for new price, we use Q1 for new quantity. So from the question we are given, we know so well that 2001 prices and 2001 quantity are the whole year. So from that now we can now deduce, you can now work with that. Sorry for that. So we can now work with what we have there. Okay, in that scenario now we have commodity. A, B, C, D. A, B, C, and D. So we have the 2001 price, 2001 price and quantity, price and quantity. So instead of me saying 2001 price and quantity, I'll just say PO, QO. PO, QO. So that reflects that it is my old year price. So my old year price that we have 14 for commodity A, 13 for commodity B, 12 and 10. Then for the same quantity I will have 45, 15, 10 and 5. Now you do the same thing for 2006. For 2006 we call it P1 because it's the current price, not the old price. So we have P1 and Q1. So P1 and Q1 we have 2019, 14, 12, 2019, 14 and 12. Then Q1 we have 35, 20, 10 and 8. Now from what we have here now, we can work further now. So we've gotten our 2006. Now from what is asked us to get, since we calculate Laspeyres, we know very well that Laspeyres formula is simply summation. Laspeyres is simply summation P1 QO over summation PO QO times 100. So we need to get P1 times QO. That means the current price times the old price. So let's go. P1 times QO. P1 times QO. So if you do P1, this is P1 times QO. 45 times 20. Yeah. P1 times QO. You have 900. So let me just, if you multiply and do P1 times QO, you have 900, 285, 140, and 60. So if you do for POQO, we have 630, 195, 120, and 50. So from here we can calculate Laspeyres index traits. Laspeyres index. So what is my summation of P1 QO? So if we add all of P1 times QO together, what are we going to have? We are going to have 1,385. That means that we have 900 plus 285 plus 140. We have 1,385. Then if we add all these together, we have 930. We have 995 rather, 995. So if you do the normal calculation, 1385 divided by 995 times 100, we'll be having 139.19. Yeah, 139.19 as your final answer. So if you approximate, you have 139 as your final answer for Laspeyres index. So let's check. What about Paasche index? Paasche index, the formula for Paasche is what? Summation P1 Q1 over P summation PO Q1. So we need to get current price and current quantity, multiplication of P1 Q1. So P1 Q1, P1 Q1, P1 Q1. So we multiply them together. P1 Q1, we have 700, 380, 700, 140, and 96. So if you add P1 Q1 together, you have 1316. So now going from there, then we have P1 POQ1, then POQ1. What are we going to have? POQ1, we have 490, 300, then 300, 140, and 40. So if you add everything together, you're going to be having 930. So doing the normal calculation, summation of P1 Q1 is 1316. So 13, don't forget this, always multiply by 100. 1316 over POQ1, 930 times 100. You're going to be having 141.50. 141.50. That is approximately 142 for your Paasche value. Now let's now move to Fisher's formula. Don't forget that Fisher's formula is just this and multiplied by 100. So you have Fisher's formula, Fisher's square root of, then what do we have for all this? For all this we've done the calculation already. Okay, let's just say 1385 divided by 995. 1385 divided by 995 times, for this alone without the 100, 1316 divided by 1316 divided by 930 times 100. So if you do that, you are going to be having, with your final answer, you're going to be having 138 approximately here. So if you do this approximately, you'll be having 138. So just divide this and multiply your answers by 100, then square root everything. You'll be having 138 as your approximated value. If you're not getting that, then definitely you are wrong. So for Marshall Edgeworth says that we should find the formula goes thus for Marshall Edgeworth. Formula for Marshall Edgeworth is simply, okay, let me write this off so that we can use that same place for Marshall Edgeworth. The formula for Marshall Edgeworth is simply summation P1 multiplied by Q1 over QO over 2 over summation PO multiplied by Q1 plus QO over 2. So we need to get Q1 plus QO over 2. That means new quantity plus old quantity divided by 2. New quantity plus old quantity divided by 2. So 45 plus 35 divided by 2. So Q1 plus Q2 over 2. That is for this. Q1 plus Q2 divided by 2. So you should get that from up there. So you have, when you do the calculation, you'll be having 40 117.5, 10 and 6.5 and 6.5. Then the next thing you're going to do is to multiply P1 times your calculated value. So my P1 times 20 times 40, 19 times 17.5, 14 times 10 and 12 times. So we have P1 multiplied by Q1 plus Q2, QO rather, divided by 2. So if you do that, you're going to be having 800, 332.5, 140 and 78. Then another thing you're going to do is to multiply the old price multiplied by your value. So old price, which is PO times 40, so 14 times 40, 13 times 17.5. If you do that, PO times Q1 plus QO over 2. If you do that, you'll be having over 2. If you do that, you'll be having 560, 227.5, 120 and 65. Yeah. So if you add all this together, you should be having 1350.5, and if you add all this together, you'll be having 972.5. So doing that calculation, so the formula is just this multiplied by this divided by this, right? So if you multiply P1 times our gotten value, which is 1350.5, so you go 1350.5 divided by this 972.5. Don't forget that there is always a multiply by 100, multiplied by 100. So if you do the calculation, you'll be having 138.86. So if you approximate, you'll be having 139 as your final value for Marshall Edgeworth. So that is all about this topic. If you have more questions, you can drop them in the comment section. Just like I have said earlier, don't forget to click on the subscription button and click on the notification button so that when we drop more videos, you'll be the one to benefit first. Thank you. See you guys in our next class. Goodbye.